Hello, and welcome back to Caroline's Chemistry. Today we're looking at one of those bonding ideas that sounds way more complicated than it actually is. Coordinate bonds, also called dative covalent bonds. So if ionic bonding is the strong attraction between positive and negative ions, and covalent bonding is the sharing of two electrons, then coordinate bonding is simply a special case of covalent bonding. So in this lesson, we're going to break this down properly, like what a coordinate bond actually is, how to explain how one forms, how to draw it clearly without panicking about arrow directions, and some real A-level examples you will definitely see in exams. So if you find this helpful, don't forget to like and subscribe, and let's get into it now. So let's start with what a coordinate bond is. Well, there's actually two names for them. You can call them a coordinate bond or you could call them a dative covalent bond. It means exactly the same thing. Now, in a normal covalent bond, what happens is each atom in the covalent bond donates one electron to that covalent bond. However, with a coordinate bond or a dative covalent bond, both of those electrons in the shared pair of electrons come from the same species. So one thing, atom, ion, etc., is donating both of those electrons to then be shared in the covalent bond. Now, sometimes you might see them therefore drawn not as sticks, which is how we draw a normal covalent bond, but rather an arrow, and that shows which direction the electrons are donated. Now, once they're formed, however, coordinate bonds are identical to other covalent bonds. And questions can often try and catch you out with this. So they'll say, for example, which bond is stronger? And the answer is neither. Like they are equally as strong because they are both covalent bonds. So apart from how they are formed, they are absolutely identical to any other covalent bond. They're still a shared pair of electrons. Now, this is how to draw a dative covalent bond. So here we have, for example, now this is how to draw a dative covalent bond. So here we have, for example, ammonia, and it's the nitrogen in that ammonia, in the NH3, that has the lone pair of electrons. So it can donate both of those electrons to the hydrogen ion, and you can see that via the arrow going from the nitrogen to the hydrogen. When it comes to explaining this, so this is the text at the bottom here, you need to be really careful about how you do it. You need to say which atom the electrons are coming from and which atom or ion the electrons are going to. So you don't just say the electrons are going from the ammonia to the hydrogen ion. The lone pair of electrons is donated from the nitrogen in the ammonia to the hydrogen ion. Say exactly where those pair of electrons are coming from and where they are going to. Here's another example. So here we have aluminium chloride, and we have a dative covalent bond forming between the chloride ion and the aluminium to make an AlCl4- ion. So again, we use an arrow to show from the lone pair on the chloride ion to the aluminium atom, that is the new covalent bond forming, the dative covalent bond. When we explain that, we say the lone pair of the electrons is donated from the chloride ion to the aluminium of the aluminium chloride. So again, we don't say to the aluminium, and we don't say to the aluminium chloride. We say to the aluminium atom in the aluminium chloride. Okay, let's see what we have here. So we have a fluoride ion. Now, fluoride ion is in group 7. So it has the lone pair of electrons. It has 7 of its own and 1 that it gained when it became an ion. We have Bf3. Now, it's the boron here that is in group 3 and is capable of accepting another electron. So therefore, we have the dative covalent bond forming from this lone pair here to that boron. So therefore making the ion where the F, the fluoride ion that joined, that's the dative covalent bond. The rest of them, covalent bonds formed in the normal way, and then don't forget full square brackets and the minus sign outside. That boron is now negative because it's in group 3. So it has 3 of its own electrons and 1 that it's gained when this dative covalent bond was made. In order to explain this, we say that a lone pair of electrons, you can hear my dog there in the background, is donated from the F- from the fluoride ion to the B, the boron in BF3. That's how to explain that for full marks. If this was helpful, then don't forget to hit like and subscribe for more chemistry videos for your GCSE and A-level so that I can help you get the best grade possible. Let's do this together, and I'll see you in the next